the course Design Practice lecture module 34 and 35. In this module, I will start a new topic that is called Axiomatic Design. So, first I will discuss what is the design. Okay. So, design is an interplay between what we want to achieve and how we want to achieve them. Okay. So, first what you are saying there, you will have to interlink both these questions in a design. Okay. So, although there are only 2 points you are targeting, but in between there are lot of steps are involved to jump from 1 to 2. Okay. So, we have already discussed variety of several methodology in design. You have already learned concurrent engineering. Okay. In this approach, you have already learned how you convert your idea into product, okay, through a various steps. Okay. Another methodology you have learned material selection in engineering design. Okay. So in this topic, what you have learned, how you will select best material for your product in a certain condition. Okay. So, in these modules you have already learned how in material selection in engineering design both questions were involved there. Okay. So, first you initiated the idea which product you want to fabricate, then you went through the various process, and after that to a final material selection. Okay. So, now in continuation with that, I will start a new topic that is called Axiomatic Design. Okay. This method was proposed by Professor Su at MIT, USA in 1990. Okay. He proposed a approach that is a basic more about a design framework rather than any principle. Okay. So, he proposed a new techniques that is called axiomatic design. Okay. So, it is a system design methodology using matrix method systematically analyze the transformation of customer need into functional requirement. Okay. Design parameters and process variables. Okay. Here in this approach, what he proposed, he just used mathematical approach to analyze the need and convert it into final goal. Okay. So, for that he used 4 domain, that was the functional requirement, design parameter, first was customer need, second was functional requirement, third was design parameter, and last one was process variable. I will discuss each element in detail in next slides. Okay. Also, axiomatic design offers a systematic and orderly way to proceed through the software development and process. Okay. So, using this method, design process can be automated. Okay. So basically axiomatic design provides you identification of a good design and how to pick the best of a set of good design. Suppose that you are going to make some product and you have a set of good design available. So which one will be best for you, that you can find the solution in that axiomatic design based out of set of good design. Okay. Also axiomatic design provides for a methodology that ensures developer make the best design decision by providing decision making criteria. Okay. So it takes you from argument to analysis in design evaluation. And this methodology is very simple and based on mathematical approach. So ultimate goal of the axiomatic design is to establish a science base for design and to improve design activity. Whatever existing design you have, you can improve using this method, axiomatic design. And how you will improve this activity? By providing the designer with a theoretical foundation based on logical and rational thought process and tools. Okay, it means axiomatic design provides you a tool for complete process. Okay. You can compare it with engineering design. In engineering design, first you make assumption which process will be correct and or not. Okay, so you are making assumption first, then after it requires iteration. Okay, trial and error method like, and finally evaluation, and generally evaluation is made by experienced people in department. Okay. So like engineering design, axiomatic design also have several steps. First, it assumes, you will have to also make an assumption here in a form of axiom. Okay, I will explain you what is the axiom later. Then it requires decomposition of your need. Okay, and then evaluation, that is the most critical parameter, and it is done by rules and axioms. Okay. So here, unlike engineering design, here experienced people is involved in evaluation process, but in this process there is already rules are available. Okay, for that. So the process is very fast and accurate. Now, so what is the axiomatic design framework? Here you can see that it has a general, in general axiomatic design framework consists of 4 domain. First one is customer domain, second one is functional domain, third one is physical domain, fourth one is process domain. Okay. So what I will explain you each one in brief. Okay. So customer domain, in this domain it relates to consumer attributes. Okay. It characterizes the design in a consumer domain. And what is the consumer attributes? It is in a, generally in a form of wishes, customers wishes, and it may be technical or non-technical. Okay, suppose that if someone wants to a car with automatic temperature controller. Okay, so customer makes a wishes, he wants some automatic temperature controller in his car. Okay, so first what you will have to do, this is the customer domain. Okay, and these are the attributes of a customer. Then you will what you will have to do, first you will have to map it in a functional requirement. Okay, that is called a functional domain. In functional domain, what does functional requirement does? It's a minimum set of independent requirements that completely characterize the functional needs of the product. Okay, so that means you have to convert customers wishes into some engineering or technical form. Okay, so there may be a, for one need, one wishes, you have a several, it may be possible that you have a several functional requirements for that. Okay, after that again these functional requirements will have to mapped again for a designing of a product. Okay, and this comes into a physical domain. In this is DP is for design parameter. How you will how your requirements will fulfill. So you will have to select design parameters for that. Okay, so it describes the design in a physical solution space, and design parameters are the physical characteristics of a particular design that has been specified through the design process. Okay, so whatever requirements you have, so you will have to choose accordingly designing parameters required. Okay, after that, and as well as here you will have to also select constraint. Okay, for that, what is the limitation for customers wishes? Okay, so after that, after choosing a designing parameters for your functional requirements, then again you will have to map into a process domain. So that is called a process design. Suppose that you have a parameters to make a bolt. Okay, so which machine will be available for fabrication of bolt? So that machine is comes into a process parameters. Okay, process variables. Here it comes fabrication process, etc. Okay, so you can see that here customers need what you need. Here in the left side, that is the customers need, and it is finally converted in a how you will get it. So this from this to this one is converted in a, it is distributed decomposed in a 4 steps. Okay, so now an all domain is in a axiomatic design, it is represented in a matrix form. So you have a 4 domain for a axiomatic design. So how it works? So first customer need, what I said that in earlier slide. Then again after getting your needs from your customer, then convert his wishes into your functional requirement. Then again you have to map it in a designing parameter. Then it if suppose that say more than, if DP has more than 1 in a number, then you will have to decompose it, so that each parameter effect of each parameter should be taken into account of solving your customer's need. Okay. After that, after decomposition of designing parameters, you just define modules for each one. Okay. So that you can make a full design matrix for that. Okay. After that, just divide it in a classes. So class 1, class 2, class 3, so that parameter can be ranked. So dp1, dp2, dp3, in such a way you will have to make a classification of designing parameters. After that, you will have to make an interface between your parameters, functional requirement, and what is the process variables are available for that will be required to achieve your customer's need. Okay. After that, if you can convert it in a coding system, then you can automate your system designing process. Okay. So it will come as a software product. So these are the this is the way to do how you will do axiomatic design step by step. Okay. So here characteristics of the fourth domain of design world. So here you can see here variety of process are available. Here domain character vectors are manufacturing. Okay. So for in a customer domain, what is the attributes which consumer desire. Okay. After that, what is the need is converted into functional requirement that is specified for the product. After that, this functional requirement is mapped into a physical variables which can satisfy the functional requirement. Again, process variable that can control design parameters. Okay. This is the constraint. Okay. So for material, if you are doing a geometric design for material, then what you have to do, first desired performance. Okay. Suppose that a customer need a lightweight cycle. So you will have to make a selection accordingly. Lightweight cycle is a functional requirement, so you have to require some properties for that, how you will make it, then what will be the microstructure for that, or other parameters like a mechanical properties or chemical properties and electrical properties, etc. Then and by which process you will going to make it. Okay. So again, in the case of software, there is attributes desired in a software. Again, you will have to convert in a functional domain, output specs of program codes, and like that. Okay. So I will discuss what are the elements of axiomatic design. Okay. So that is called axioms. Axioms is a self-evident truth or fundamental truth for which there is no counter examples or exception. Okay. It can't be derived from other law of nature or principle. It's just a hypothesis. Axiom is a hypothesis and it can't be supported by any law or you can't validate this hypothesis. Okay. So it's based on hypothesis. So various statements are available regarding axioms, and these are: first, a statement that is stipulated to be true for the purpose of constructing a theory. So the statement was given by Harper Collins in a dictionary of mathematics. Okay. So what this statement said that, so there is you will have to make a statement for a particular design process, and there would have that will be only hypothesis only. Then another statement is that fundamental truths, axiom are the fundamental truths that are always observed to be valid and for which there are no counter examples or exceptions. And this was given by Professor Su, professor in a department of mechanical engineering, MIT, USA, and in a book Principle of Design. Okay. And third one, axioms are posited as accepted truth and a system of logic that is built around them. Okay. So you can see that these are the only hypotheses only. So they have no any base and support of technical support. So axioms, you will have to make an axiom for your design process. So in a broad way, the design axioms can be classified into two parts. First one is the independence axiom. And what is the independence axiom? It maintains the independence of a functional requirement. it indicates that the aspect in the preceding domain should be independently satisfied by the choices carried out in the next domain. Okay. And second one is the information axiom. Here the primary purpose of this axiom is that minimize the information content so that you can make the design independent. Design independency is required, and you can achieve by minimizing the information content so that your matrix will be uncoupled and all parameters, designing parameters will be independent with each other for a particular functional requirements. Okay. Here, so first I will explain the first axiom, the independence axiom. Here, so for your any axiomatic design process, first you will have to make a design matrix, formation of design matrix. Okay. So here what is the design matrix? It is the relationship between your functional requirements and designing parameters, and that can be written as in a matrix form. Okay. FRS is equal to A into DPS, where A is called a design matrix that relates to functional requirement and designing parameters. Okay. Here A relates functional requirements to designing parameters. Okay. So it's a interlinking, it interlinks each other. Okay. And characterize the product design. Okay. In a another term, you can write it in a ratio term, that is the differential functional requirement in differential form divided by partial differentiation of designing parameters. Okay. So here I will take an example how you will write a design matrix for your particular problem. Okay. Here design matrix is of the following form. Suppose that we are giving a design which has a 3 functional requirements and 3 designing parameters for that. Okay. Here that is the design matrix for that. Here A11, A12, A13, A21, A22, A23, these are the non-zero term, and each has a some significance, and it has a it relates with it makes relationship between functional requirements and designing parameters. Okay. So if you want to write in a matrix form for this one, so how you will write it? Because you have a 3 functional requirement FR1, FR2 and FR3. So according to equation 1, we can write it A11, A12, A13, 22, A23, A31, A32, A33, and we have also 3 designing parameters, that is DP1, DP2, DP3. So if you write in a extended form, so what will be? FR1 is equal to A11 into DP1 plus A12 into DP2 plus A13 DP3. Similarly, you can write FR2 is equal to A21 A22 into DP2 plus A23 into DP3, and again for third functional requirement A31 DP1 plus A32 DP2 plus A33 DP3. So here you can see that all functional requirements are, there is a relationship between functional requirements and designing parameters with the help of this design matrix. Okay. So the above equation can be written in a differential form as DFR is equal to A into DPS. Okay. So in a broad way, in a functional requirement is equal to design matrix into matrix of designing parameter. Now types of design matrix. In a broad way, there are three types of design matrix. First one is uncoupled design. Okay, when the design matrix A is diagonal, each of the FR functional requirements can be satisfied independently by means of its respective designing parameter. Such a design is called uncoupled design. Okay, so for the independent axiom, what was the equation? FR is equal to design matrix into designing parameter. Okay, so here you can see that if design matrix is a diagonal matrix only in a there is a non-zero term in a diagonal only, and rest of the elements are zero term. Okay, so and if you are making a matrix for that, suppose that for FR1, FR2, FR3, three functional requirement is equal to A11 0 0 0 A22 0 0 0 A33 into you have a three designing parameters, then you can write it FR1 is equal to A11 dp1, FR2 is equal to A22 dp2, and FR3 is equal to A33 into dp3. So here you can see that all the designing parameters are independent. Okay, these parameters are related only with the functional requirement 1, dp2 is related only with the functional requirement 2, and it has a no effect on functional requirement 3. So this is called independent design. So for a better good design, their matrix should be uncoupled. So each parameter will be independent with each other. Second one is decoupled design. Second type, when the matrix A is triangular and the independence of functional requirement can be guaranteed if and only if the designing parameters are determined in a proper sequence. Such a design is called decoupled design. Here you can see that this is the triangular matrix. Okay, and if you will write again similar to this matrix FR1, FR2, FR3, here A11, A21, A31, 0, 0, A22, 0, A32, A33, and dp1, dp2, dp3. So after solving, what you will get? FR1 is equal to A11 dp1, FR2 is equal to A21 dp1 plus A22 dp2. Okay, so similarly you can write for FR3 also. Okay, here you can see that suppose that first you in a functional requirement 1, here dp1 is related to functional requirement 1. Okay, here first and if you have determined functional requirement 1 with the help of dp1, now you have to make it fixed, dp1 fixed. Then in a second step, the FR2 is satisfied only if that dp2 will be satisfied by FR2 and dp1 is already fixed. Okay, so here you can see that if you design parameters are in a proper sequence, then your functional requirement will be independent. Okay, so here because here dp1 is fixed and you are moving only varying only dp2, so and dp1 is fixed. Okay, so it means although it includes dp1 is included in this equation, but it has a no effect. Okay, only if dp1 is you have make a fixed here. Okay, for functional requirement 1. So similarly FR3 if you will write here, so what will happen for FR3? So all parameters will be included, FR3 A31 dp1 plus A32 dp2 plus A33 dp3. Here dp3 will satisfy only FR3 only if only dp2 and dp1 will be fixed. Okay, so although this is the decoupled design, but here parameters are independent. Okay, now third part is coupled design. Any other form of the design matrix apart from diagonal and triangular, So that will be a, that will make you a full matrix and result in a coupled design. So here you can see that there is a full matrix A11, there is no any zero parameters. Okay, so there is a final equation is that like this one, and this is the no sequence of designing parameters can satisfy the functional requirements independently. So coupled design falls under the bad design and uncoupled design falls into a good design. So always you will have to focus to make a matrix such that it is a uncoupled design. Okay. Now I am taking one example to explain how you will formulate design equation, and I am giving one example of mechanical pencil. Suppose that you want to make a pencil, and there is a customer need. After your you have make a questionnaire from customer, and those needs is converted into functional requirement. And what are the functional requirement? First one is erase lead. So it should have a facility to that lead will be get erased. Import and store eraser. They have a storage facility of eraser. Import and store lead. Lead can be changed in that pencil. Advanced lead, support lead in use, and position lead in use. That is the for aesthetic part. Okay, these are the functional requirements for your fabrication of your pencil. So here your functional requirements will have to mapped in a designing parameter. So what are the designing parameters? First one is eraser. You will have to make use of eraser so that lead can be erased. Opening for eraser, cylinder with stopper, spring lead advancer so that there will be a much smoother writing, chuck to hold lead, and external grip to hold pencil in a better way. So if you are going to make a matrix using your functional requirements and designing parameters, so what will be design matrix? Here you can see that this is the design matrix. Okay, A is design matrix and the other design, this is the design equation. Here you can see that in this equation, erase lead. Lead can be erased only with eraser. So here other parameters are 0 and only x is there, that is the non-zero parameter. Okay, value. So if you will write fr1 is equal to what will be? frm1 is equal to x into dp1, and this is true because lead can be erased only using eraser. Similarly, import and store eraser. Here you can see that there is a two non-zero value. Okay, so if you write equation for that fr2, what it will be? X dp2 plus x dp3. So here two designing parameters which is required for that your functional requirement 2. Okay, and so again here you can see that there is a 4 non-zero parameters, and in a from the previous slide you can see that in this matrix not a neither a triangular matrix and nor a diagonal matrix. So it will be a just coupled design. So whatever you have made a matrix, and this is not a good for your fabrication of pencil. The matrix form indicates that the design is not uncoupled and nor is it decoupled, because for uncoupled you should have diagonal matrix, diagonal design matrix, and for decoupled you should have triangular matrix. Okay. The current design does not fulfill the independence axiom. Each individual functional requirement is not satisfied by fully independent physical components or subsystems. Here, for example, you can see that here for to satisfy the functional requirement 2, there is a 2 designing parameters involved. Similarly, for in a case of FR3, there are 4 designing parameters involved to satisfy one requirement. So this makes a very complex. It increases complexity of your program. So that's why it is a bad design. Now I will talk about constraints. So after your functional requirement and designing parameters, you will have to take consideration of constraint. What are the constraints are available for your design? Constraint provide the bounds. It's a limitation. It will provide you limitation on the acceptable design solution and differ from the functional requirements in that they do not have to be independent. Okay. So that is the limitation of your design. Process. So there are variety of constraints in a but in a broad way we can divide it into two kind of constraint: input constraint and system constraint. What is the input constraint? Input are specific to overall design goals. All designs that are proposed must satisfy these. It may be in form of current, voltage for designing of a transformer. System constraint that are specific to a given design. They are the result of design decision made. Okay. So they are the two basic constraint that is always available in a geometric design process. Now I am giving you another example: design of a refrigerator door. Here there is a two kind of refrigerator is available. Here gate will open like this way, and in this case gate will open like this way. So that is the horizontal hung door, and it is vertically hung door. And so we will have to decide which one has the better design, but design, so you can't say in a broad way which one is the better design. Always you will have to focus it on what is your requirement. A designer will ask you what is your requirement, then only he can say which one will be better for your purpose. So first you will have to decide your functional requirements. So what are the functional requirement? Functional requirement one is that provide access to the items stored in a refrigerator. And second requirement is that minimize energy loss. Okay. Here is only two requirements are available, and on basis of that you will have to select which one is better. First requirement is that provide access to the items placed in a refrigerator, and second one is a minimize energy loss. Okay. So first I will analyze vertically hung door. Here what is your design parameter for will be for that purpose? So design parameter 1 will be vertically hung door, and designing parameter 2 will be thermal insulation in a gate, so that energy loss can be minimized. Okay. So if you will write in a matrix form, then FR1 FR2 equal to x10 x1 x2 dp1 dp2. So FR1 is equal to x1 dp1 and FR2 is equal to x1 dp1 plus x2 dp2. So here you can see that there is a triangular matrix, designing matrix. So this design equation is decoupled one. Here you will have to rely more than one parameter for a particular requirement. Okay. Here you can see that for vertically hung door, if you will open the you will make a horizontally hung door, then your first requirement will get fulfilled. Okay. But if you will open the door at the same time energy will be get evicted from your fridge. Okay. So, there will be energy loss. So, here x1 and x2, they are two non-zero term in a design matrix, and it involves in to fulfill a criteria of functional requirement 2. Okay. So, however, when we open the door, what will happen? Energy loss occurs due to x1 into dp1 plus x2 dp2. Okay. So, for to fulfill functional requirement 2 and functional requirement simultaneously, this one you will have to make a fixed, then only your FR1 and FR2 will be get independent. Okay. So, in case of horizontally hung door, horizontal type, here design requirement parameter 1 is horizontally hung door and parameter 2 is thermal insulation. So, for that designing equation FR1 FR2, here this is the diagonal matrix, and here you can see that you have a 2 designing parameter and 2 requirement. So, that is the for ideal case, and x1 and x2 is placed in a diagonal form. So, it is a uncoupled one. Okay. So, you can see here both parameter dp1 and dp2 is independent in each case for functional requirement 1 and functional requirement 2. Why? Because when we open the door, cold air will remain in the refrigerator. And energy loss can be minimized. Okay. So, here in this case, for that particular functional requirement, you can see that horizontal type is better than vertical type refrigerator, but this is always not fixed. Better design for particular requirements. Okay. So, for different requirement, the design may be changed. Okay. So, it may be possible that for certain requirements vertically hung door will be better. Now, what is the ideal design, redundant design and coupled design? Again, you can distinguish your design in a another form, that is for case 1, if number of designing parameter is less than number of functional requirements, that is called coupled design, that is called bad design, bad one. Okay. Here what they are saying, when the number of designing parameters is less than the number of functional requirements, either a coupled design result or the functional requirements can't be satisfied. Suppose that here you can write it FR1, FR2, FR3, there are 3 requirements and you have a design matrix. Okay. And you have only 2 designing parameters. So, in that case, the design matrix equation will be coupled design. Second one, case 2, if number of design parameter is greater than the number of FRS functional requirements, then it is called redundant design. So, you can see here, if here you have only 2 requirements and there are 5 parameters. If design parameter 1 and design parameter 4 are varied after dp2, suppose that dp1 and dp4 is varied after dp2. So, here they are talking about sequencing, and dp5 is fixed to control the value of functional requirements, then design is a coupled design. Okay, because here what are the how many variables are there? 1, 2, 3. Okay, so in second case, if we fix the value of dp1, dp4, dp5, dp1, dp4, dp5, then there are only 2 design parameter and 2 requirement. So in that case, it will be uncoupled design, best one in that condition. Okay, so third condition, if dp3, dp4 and dp5 are fixed, dp3, dp4 and 3 all are fixed, then the design is called decoupled design, because here you if you make equation for that fr1 fr2, there in each requirements the involvement of both parameters will be there. Okay, so here for that case, if you will write fr1 is equal to a11 dp1 and fr2 is equal to a21 dp1 plus a22 dp2. So here you can see that this is the case of decoupled design. So if in last one, if dp1 and dp4 are set first, and then the design behaves as an uncoupled redundant design, and in this case you are not neglecting anyone, and you are taking consideration of all the things, but you are making dp1 and dp4 before then the other parameters. So it is uncoupled, but still it is a redundant design. Now in case 3, that is the if number of design parameter is equal to number of functional requirements, so in that case that will be the ideal design. So your objective should be always to make a ideal design. In ideal design, the number of design parameters is equal to the number of functional requirements. Okay, and benefit of that, functional requirements are always kept independent from the each other. Okay, so suppose that if you have more than the you have suppose that 4 functional requirements and you have a 6 designing parameters for that. So you will have to eliminate 2 designing parameters using the second axiom. So I will explain what is the second axiom later. Now decomposition of functional requirements and designing parameters. So in ideal condition, functional requirements and designing parameters are very few in numbers, but in actual condition there are lot of functional requirements involved in the fabrication of one product. So in that case, you will have to decompose your product in a variety of sub elements, so that you can make involvement, you can take in consideration of each elements in your design consideration. So I am giving you one example for how you will decompose your functional requirements as well as your designing parameters. Okay, now here you can see that this is the decomposition of functional requirement and this is the designing parameter. Okay, here you can see functional requirement is divided into various sub element fr1, fr2, again fr1 is subdivided in a fr11, fr12, here similarly fr21, fr22, and here also correspondingly designing parameters is also divided in a various sub parameters, and each parameters is linked to sub elements. Okay, functional requirements, here fr21, fr22 is linked to dp1, you can see an example. So here you can see that you have decomposed your functional domain and as well as physical domain. So for example, decomposition process for a lathe using a axiomatic design. So for lathe, what you will have to do for lathe, what is the function of lathe? It is a metal removal machine. Okay, so for metal removal device, what are the functional requirements? You have a functional requirements. So these are your functional requirements. Power supply, workpiece rotation source, speed changing device, workpiece support and tool holder, support structure, tool positioner, and again here you can divide it a workpiece support in a various form, tool holder, positioner, support structure. Again you can divide in your tool holder in sub functions. So tool holder may be longitudinal clamp, rotational stop and tool holder. So how in this way you can divide your functional requirements. Okay, now After your decomposition of functional domain, you will have to decompose also your designing parameters accordingly. Okay, here you can see that for a lathe there are a lot of parameters are involved in a process: motor drive, headstock, gearbox, tailstock, bed. Here also tail, this one is divided into frame, spindle, feed screw, frame. Again your spindle assembly is subdivided into clamp, handle, belt, pin and tapered bore. So what you are doing here? So you are dividing your main functional requirement. This was your main functional requirement, and you are dividing in various requirements, FR1, FR2, FR3, like that. Okay, and similarly here you are your first designing parameter to for a material removal process is the lathe machine. Okay, so this was the DP, and for designing that lathe machine you have to divide it in a various parameter. So each parameter is involved in a machining process. Okay, so this is the how you can decompose your process. Now earlier I said that if there is a more than number of designing parameter is more than functional requirement, so you will have to reduce your designing parameters, so that that design system will be a good design. So what is the second axiom? Axiom is a hypothesis. Okay, so here what is the goal of information axiom? The minimize the information content of the design. Okay, and it is mathematically it is represented as I is equal to log base 2 1 by PS, where PS is the probability that a product can satisfy all the functional requirements, that the it's called probability of success. Okay, and here base 2 is only used to express the information content with the bit, because your final goal is to convert it in a software for your design process. So you will have to convert your mathematical value in a bit form. So that's why here 2 is taken. So what we will have to do for minimization of information, here only one parameter is variable, that is the probability. So probability of success will have to maximize the probability of that success. Okay, so that your information content will get minimized, and this information axiom provides a theoretical foundation of your robust design. And one type of robust design, that is called Taguchi design, you have already learned in a concurrent engineering module. Now I am giving one example for that, how information axiom is calculated mathematically. Suppose that for a system, design system, you have 3 functional requirements and as well as 3 designing parameters, and it's a diagonal matrix. So it's a it is that is fall into a uncoupled design. Okay, diagonal matrix. And let us suppose that P1, P2, P3 are the probability of satisfying FR1, FR2, FR3 with the parameters, respective parameters DP1, DP2 and DP3. So so if you are going to calculate information content for that design, so what it will be? It will be summation of, you have a 3 parameter and 3 functional requirements. So you can write in a way log 2 summation of 1 by pi. So this is the information content for your this uncoupled design example. Now I am giving you one real example, that is the bottle can opener, and we are going to calculate information matrix for that bottle can opener. This is the bottle can opener. Using this you can open your bottle, beverage bottle, as well as your aluminum can. Okay, so it has a more than 2 functionality. So it is available to open both of these. So what are the functional requirement for this problem? Design a device that can open bottles and design a device that can open cans. Okay, so you are making a one device which is capable of open either beverage bottle or can. So for that purpose, suppose that probability of satisfying functional requirement 1 with dp1 is 0.95 and the one for fr2 with dp2 design parameter 2 is 0.85. Then how you will calculate information content? So I will be I1 plus I2, and we know that I is equal to log 2 1 divided by probability corresponding. So we will take 0.95 and plus log 2 1 divided by 0.85. If you will solve it, so what will happen? 0.0739 plus 0.2345. So that will be equal to. So this is how you will calculate mathematically your information content. Okay. So this is how you designing your process. Okay. So this is your calculation for axiomatic second axiom. Okay. Now what are the strengths of the axiomatic design? So first you can, there are variety of benefits are available for axiomatic design. So what are the strengths? That first one is mathematically based, second one is vehicle to related functional requirements and designing parameters, third one is the powerful if the relationship is linear. So if there is an equal number of functional requirements and designing parameters and both are the independent, all functional requirements are independent with their corresponding designing parameters, so that is the then relationship will be very powerful and your design will be good, very good design. It provides a procedure for decomposing decision process. Okay. So your idea of thought can be decomposed in a mathematical way in this design. So it's a very authenticate tool for a designing process. Then last one is basis for comparing alternative design. So it provides you a comparative study you can do with the other comparative design concept. So because whatever you are getting here is in a mathematical form. Okay, so that you comparison is very easy with other designing process. And there are also some weaknesses associated with the axiomatic design. First one is itself, axiom is a selection of axiom because it's a hypothesis. So you can't argue with that your axiom on the basis of your technical information. So always you will have to make a proper selection of axiom so that your design will be a good design. Otherwise, if you have selected wrong axiom, so it may be possible that design is not good for that process. Then second one, third randomness, chances of repetition, because there is a variety of randomness is available in each domain. So it may be possible that some very parameters get repeated in your matrix and it will increase your complexity in a design. Third one is designs are usually coupled. In a real practice, it is very difficult to find a uncoupled design. So designs are always related. One requirements are related with the more than one designing parameters. So you will have to always minimize your designing parameters and information content so that your design will get converted into coupled design. So it is very tedious task. And last one is axiom 2, that is the minimization of information content. That is I said earlier that information it is very easy, looks very easy, but it is not a very easy process to reduce the information content, because when you will start doing designing process, then you will find that some parameters are very difficult to remove from your process. Now axiomatic designs have a variety of applications. The applications are, it helps in decision, mainly design decision making process. Sometimes it is also called design decision making process. So it helps in a correct decision, it shortens the lead time, it improves the quality of product, deal with complex systems, simplifies service and maintenance, and enhances creativity and as well as productivity improvement. it offers a systematic and orderly way to proceed through the software development process. Okay. So, in this process you have learned that in the axiomatic design is a very convenient way to convert your hypothesis into a mathematical form, so that you can represent your idea in a some standard formulation, and you can optimize for it and make a software for that, so that next time when you will going to design new product, then that software will help you to development of that new product. Okay. So, now I am closing this module, and in the next module I will discuss something new topic. Okay. Thank you very much.